Well, let's have a little look at some of our surface geometry stuff. So this is one of our first questions with roofs. Okay, we're looking down on the roof of a house in plan view or bird's eye view. Okay, and we can see it's kind of this little funny structure. All right, so that's this, these bits here would all be on the ground. Those edges are the ground. Really, what there is at the top of the walls of the house. Okay, but we'll consider it the ground to make life a bit easier. This is the high point of the roof, the apex of the roof. All right, so this is going up, up, and up. Now, the new thing we have here is the idea of pitch. All right, and pitch is just the angle it's going up. So D is going up like that at a pitch of 60 degrees. It's a very steep pitch. All right, C is a bit shallower. It's only 40 degrees. So the pitch is the angle between the roof surface and the horizontal. Think of it as the attic floor. Now, we got to draw this a little bit of thinking around. There's no new ideas beyond the concept of pitch. That's just a different bit of language. All right. All the time here, we're looking for how can we look at this to see it? How can we translate true lengths and true shapes? Okay. So there's loads of ways to do it. I'm just going to kind of poke my way through it. It's a fairly big plan, and the elevation will probably be smaller. So I'm going to put it a little bit further up the page than half. Okay. So we'll draw this out, and we'll just stick it in the middle because we'll probably need some constructions either side. So there we go. Now, just make sure we can see this nice and clear. Happy days. Okay, so we'll stick with our usual 20mm gap just to make things neat more than anything else. So there's a 20mm gap, and we'll throw that as construction line there. Okay, so that's the top of my plan. And I guess we just need to start. So we have these here, 4, 5. Now, these are 4 meters and 5 meters, and that is a pretty big sheet of paper. But of course, we have a scale of 1 to 100. So a really good tip is 5 meters goes to, okay, and it's going to be 50 millimeters. Now, how did I get that? 5 meters is 5,000 millimeters. Divide 5,000 by 100, I get 50. And at that point, you can see what 4 meters is obviously 40 millimeters, 8, and so on and so on. Okay, so you can write them down if you need to. On 1 to 100, you might get the hang of it and see how it's going to go. So we are going to come across. So we'll take a nice starting point. I'm going to use my marks on my set square. Okay, so that's there. That's the 40, and another 5 is out to here. Okay, and we can just throw it as a construction line the whole way down because that will go up to the roof. Now, how far down does it go? It goes down 8 plus 2.5, so that's 10.5 meters, so 105 millimeters. There we go, and up 2.5. Okay, what else have we got to figure out here? This is going to continue down. So we'll build it up as construction lines, and then we'll heavy in what we need to heavy in. So that's the edge of C there. There we go. And yes, this goes down by 8 meters. Actually, there's our 8 measurement there. So we'll send that across. Kind of like use the ones you have rather than remeasure and risk making a mistake. It's a little bit off there, so we'll just draw that like that. Now, I can't draw all of these bits in because, as you see, when I come to here, something's happening with C and there. I don't have that information yet, so I'll just leave it blank. Now, you could realize that because A and B are going up at 45 degrees, that apex is going to be in the middle, so it's going to be at 40, but I'm going to show you another way to do it, okay? And we'll project a few of these guys up. Now, so this part of D is on the ground. So let's do our first little bit of work in pitch. We don't know how tall the roof is. We know that D is going up at 60 degrees. So this is going to go up here at 60 degrees. Okay, you still don't know how high it's going to get yet. That's a problem for another day. So what else do we know? Well, we know that A and B, okay, so this is kind of D somewhere around here. That's A, and that's B. That's C down here. No harm to label them. A and B both are going up at 45 degrees, like this, and going up like this. So if we were to look at them this way, we'd be able to see that side of the roof. Okay, it would look something like that. Okay, 45 and 45. Well, let's just do exactly that, and that's what we're going to do in auxiliary view. You'd get it in an end view, but I wouldn't even go to the bother of projecting up and putting it here or here. You don't need to. So let's just do this out here. Now, because I've had a look at this question and had to think about where it's all going to go, I am going to actually push this out a bit, okay? If you're doing this in an exam on big paper, don't be afraid to use a whole page in case you need to, okay? It's not the end of the world, but there is a little bit of a reason to push it out further, which we will see along the way. Okay, so this bit's on the ground, or on the top of the walls, and we know it's going up at 45. Up it goes, up it goes, and there's the middle. Okay, so that's A, looking at it there, and that's B. That's the apex, somewhere along there. We don't know where it stops yet, we'll have to figure that out. So how can we use this to solve it up here? Well, it turns out we have the height. So if we just color this in a fabulous orange here, call that H1, that's an auxiliary elevation, so that's how tall it is. Let's grab our compass, which we have carefully ready. There we go. So we'll use this to copy H1. Again, better use it with your compass than trying to measure it and making mistakes. There's H1. Okay. And now I know how tall the whole thing is. So I can come back across from here to wherever it meets D. And there we go. We'll just put a few heavy lines in while I'm at it. Okay. I also know where the apex ends, so I can bring that down here. And that's the main apex of the roof. We're just heavy in this edge. So that, of course, is D, looking at it from the side. And, well, we know we just connect the dots here. Okay? That's where it starts to go down. That's where it ends. Ta-da. So now we've got 3 out of 4. Okay, what are we going to do with this guy? Well, C is pitching up at this kind of an angle. So actually, if we look at this way, we'll see the angle there in the elevation. So it turns out this isn't actually so bad after all. There we go. Get a protractor. Now if you look at the drawing, okay, now you may or may not realize this from the drawing, but it's not quite going to reach the apex. So I'd expect C to be somewhere around here. So 40 degrees, let's pop this down. Okay, lined up nicely. And come around here, and again, just watch as you do these guys. It's always tempting to use the big longer markers, which come from the other ones. Coming around here, 40 degrees, there it is. And that looks pretty good, what I'd expect. There we are. That's C. Where does it go here, though? This is a slightly trickier one to think about. Okay, so what do we know? Well, I'd like to know the real height of it. Okay, so I got this height from this auxiliary elevation. So I wonder, can I use this height and put it back here? Turns out I can. So we'll just extend this up in order to do a construction. What we'll do is we'll take this, I think we'll use our lovely green for this one here. This shorter height there. Height of C is going to be called H2. How high is it? Well, let's see. I don't care about the number, I just want to set it, be able to reproduce it. So that's H2 there. So we'll stick it out on the edge because I don't really know where it's got to contact. So we'll just do a construction on the edge. So just to remind you, this is H2. So you can see this is really good practice as we move around our different views. Okay, that's why I like bringing this topic in. It really reinforces the rest of the stuff you're going to do. So let's make a collection of all the points that are at H2. Well, we know that this is going to intersect surface B, because you can see it's going to be there. So it's this point that I'm interested in. And look, we can just bring it back. There it is. Same way we projected these across the auxiliary, we found it here, we can bring it back. So the auxiliary works both ways. You can bring information to it or from it. And there we are. Ta-da! So we'll just heavy end this little line here, and we can see the whole of surface C. Okay, so there's all my surfaces. This is B that we're looking at here, and that's C on the edge there. Now, what are we going to do next? Let's go back and have a look at our question. We drew the plan and the elevation. Fabulous. Develop surfaces B, C, and D. Okay, so this is the kind of stuff, this is essentially finding a true shape of the surface. All right, we can find them separately. They don't have to be all intertwined together necessarily, unless they specify that, and that does happen sometimes. But for today, we can deal with them separately. All right, that's kind of useful. It's a way to see the true area of the shape if you're calculating tiles in a roof or something like that. So there's two ways to do these, of course. We can either do an auxiliary looking at them, or we can rotate them. Almost always in these cases, it's going to be easier to rotate them. So let's work our way through it. How are we going to flip all these out? Well, we'll do D first, because D is actually the easiest one to see. Imagine that surface D there. Well, we're just going to drop it out there, just like we would have done in Junior Cert. Okay, and what we need is we need to choose an axis. If you can choose the one on the ground, it's a little easier to work with. It's not necessary, but it is a bit easier. So this is my axis, okay? And it looks like a point there, okay? As we see it that way. So we just rotate it around. So we'll take the top of D with our compass, rotate it around till it hits the ground. I have to extend my XY line out to see that. Okay, so that's where it hits the ground. And we just project that down. Now, as it rotates, the apex doesn't move sideways or anything like that. You can see it here. This point just tracks along in a straight line. So it tracks along like this, and it ends up there. All right, so again, we'll just do this. We'll give this a nice color, why not? So this is going to be my developed surface of D. Okay. Not going to fit development, so develop of D, you get the idea. Okay, and that's it there. That's what D looks like, folded out nice and flat. Okay, and again, when you get these ones, sometimes the order they're given is a nice hint for what to do with it, but you know, if you don't like the order, you can move it around a bit. So let's look at B and C. All right, how are we going to do these guys? We're going to try and do them without overlaps. So what I'm going to do with C is I'm going to put C out this way. Okay, and that's why I left a bit of a gap here. All right, so we'll take C and we'll use this as my axis. Okay. Okay, I can see C as an edge view here, so that's how I know I'm going to pick an axis in it. We'll rotate it around, and it's going to end up flat like this. So a little bit higher up. So while it's easier to visualize on the ground, there's no actual technical need to do it on the ground. So we'll take C, get our compass in there, and around we go. Okay, so just to show you, I'm going to go back to D for a second. That would have been D on the ground. Okay, and this is C kind of flat in the air. Okay, let's see there. Well, it's rotating around like this. So it's these 2 points they're going to carry across. These two stay exactly where they are. So we'll project down. Oh, look at that. It just fits nicely. Okay, so this point ends up here. And this point has to get extended. And it ends up there. All right. So now we'll do this in an orange as well. There we go. Just connect all the dots. So if you've done this in Junior Cert, this is just the true shape you'd done in the question 1 orthographics. Nothing different to that. Okay. Oh look, we've got the whole word in here. Development, just about, of C. There we go. It's not too bad. There's loads of other ways you could have done it. It's probably the easiest. I could have flipped it around this axis and put it down the ground, but I'll overlap B and I can kind of see that I'm probably going to put B down this way. So that's why I've just tried to avoid things a bit. Again, B could have gone up this way too. Usually, it's the less overlap you have, the easier it is to work with. Okay, so that's C and D. We'll do B down here. So this is going to be my axis for B. Now this is a bit trickier to see, but if that's my axis for B, how can I see it as a point? I can see it here. Okay. That's the point. Because this edge from here to here, and I'll just put that in heavy so we can see it better, is of course B. So you can see B is a little bit more complicated than the rest of them. I'll just put in A just for completeness. But I can see the edge view of B here. So you want to see the edge view when you're rotating them. I'll choose this as my axis. I'll rotate it down. Now here's a nice little trick you can do with this one. All right, that's my axis there. Rotate it down. We'll make sure we're fully on camera here. Yep. And there's the top of it. Oops, don't you go jumping at me. All the way down. And across. Because of course, I mean, what I want to really do is copy that distance to here. But there's no need to mess around my compass. I can just project it across. I can just come straight across. Like that. So this comes around, around, around. We'll use a lovely green one just for, because there might be some overlap here. So this is going to be B. Down flat, looking from the side. Send it back this way. Those 2 points don't move. These ones do. They move in this direction. So they're there. 2 of them here. So be careful, there's 5 points on B. So I'm not quite done yet, am I? Let's think about this for a second. I can connect the top together. I can connect this edge to here. Okay, so that edge hasn't moved. That edge is there. The apex is here. But I've got this little guy here. Alright, so we need to see where that comes. Well, it came from there. So we just need to do a second piece on the rotation. There it's there. It's just easier for me to go down to up just because that's a bit more awkward. The same mark. So this guy goes down as well. Round, around, round. That's where C intersects. So now we can just send it across. And there it is there. And we'll bring that back. We do have some overlap. It's not perfect, but look, we'll live. Okay. So this is the development of C. B even. Okay, and we'll throw a little bit of shading for you there. Grand, now we're nearly done. Okay, that's all the bits you may not have been used to. Of course, we do have our good old friend dihedral angles. And even though I was harping on about these all the way through autumn time, you're going, oh yeah, got those things. Why does it make such a big deal? This is why. They come up all over the place. Okay, they're very easy to put into a question. I think the examiners can't resist the temptation. So between B and D, well look, there is my line of intersection. I need one more point from each of them. So I'm going to choose the ones on the ground to save me having to do any measurement. So I'll just label them so we know what we're talking about. 1, 2, 3, and 4. Any 3 points is fine. Remember, you don't need all the points. I don't need to be bringing all this across. So let's go off and do it. At this stage, it should be completely second nature to you, but sure, I'll fire through it just in case, because it is worth the practice. There we go. So that's my X. Okay, I'm just coming clear of the drawings here. All right, there we are. X1, Y1. That is, of course, parallel to 1, 2. And that is, of course, off the page, but it does, what it says is there, is we'll try it again, parallel to 1, 2. All right, now let's bring our other points across. Now, there we are. So once we get one line, I'm going to switch these around and do parallels, but it's, there we are, there's one. Okay, you can see 2 isn't going to really fit there. My total height, okay, let's see where these are on plan. That's 1 up there, that's 2 down the bottom, 4 is behind it, and 3 is somewhere over here. 3. So how high is 1? There it is. There we go. That's 1. All the rest are on the ground, which makes this nice and easy. And we'll just do it as parallels. Again, it's easier. It's 4. Now, the reason I'm not numbering them is because you don't want to connect the wrong ones in the wrong order. And there's 2. You just have to extend that out. So that one there was 3. Extending out here. And we're going to get to 2. Okay, 1 connects to 2. There we go. 2 connects to 3, 3 connects to... So 3 does really connect to 1, because remember we're taking that little slice of it. Alright. And 1, 2, 4, 1, 2, and 4 connects to 1. I don't know what that is outside my door, but it's a crazy sounding thing. Alright, so this is auxiliary 1. Auxiliary 2 is a long 1, 2, and this is actually going to tuck in nicely on the page here. So let's see how we go. So we'll just project down here. Okay. A long 1, 2 for auxiliary 2. Now, I don't have a whole lot of space, but let's see how we get on with this. Now, just a small tip. The reason I switched here is the shadows are being cast by the way the light's falling. It's much easier for me to see what's happening. So there we are. That's X2, Y2, and I can see they're going to come down, so that'll all fit. X2, Y2. How big is it going to be? It's going to be that big, which is going to be off my page. What do? We do a measuring line. So we'll just pop this in blue so we can see it. Measuring line is parallel to X1, Y1. And we'll bring it back to 4 because that means that's one less thing to actually have to measure. There we go. You'd use a pencil. I'm just giving you a nice little color, and I've run out of coloring pencils. So measuring line M sub L. Sometimes you see it written as datum line, D sub L, same thing. Okay. Now, how far are 1 and 2? This far. Okay, so this is the only bit people get a little bit tripped up on is how to measure those ones. So that's 1 and 2. See, there's a nice little point. 1, 2. 4 is on the line and 3 is further out. So let's just project this down. And just take the time to get these parallels right. Don't want to rush them. It's not worth the hassle. Okay, we knew 4 was on the line. That's fine, that's 4. So there's one of my lines. 1, 2, 4. Okay, so this is 1, 2, 4, which equals, of course, surface D. And 3 is a bit further out. Let's go and measure 3 from the datum line again. Out we come. There's 3 along the sky. See if we're still on camera down there. No, I'm going to scoot this up a small bit there so we can see it. There's 3. So again, I've just taken that distance there down to there. There's 3. And we connect 1, 2, 3. You don't number them, the temptation is to connect these guys or something kind of wrong. So that is surface 1, 2, 3, which equals B. Dihedral's in the middle. Have a quick little measure, let's see what I get here. Now I'm measuring around this way, so I'm on the outer ones, and I am at 112. Okay, once you're somewhere in the 110 to 115 degree range, you're on the right track. All right, off you go. Have fun.